Hi, I'm Cassie, and I'm going to walk you through question 48 of the AAMC's official physics question pack. And this is going to help you prepare for the MCAT. So this question 48 is still related to passage 7, which is about if you take an object and launch it up into the air. And specifically, we want to know if you have a recording device that's underneath that object when you launch it up, how is its frequency going to change in its flight upwards and then back to the ground? So let's break that down. So in other words, we have our recording device here, and then we have our object, I'm just gonna say O for object, that's going up, and then of course at some point it's going to come back down too. So this question is sneakily testing the Doppler effect. And remember, we talked all about the Doppler effect in passage 3. So go back and review all those questions from passage 3. So remember, what the Doppler effect is the idea that when you have two objects, one is making a sound and the other is recording or observing the sound, the thing that's measuring the sound is going to hear a frequency that's different than the actual frequency the source is emitting if there's relative motion between the object, where those objects are either getting closer together or farther apart. So what is what in our case with our projectile here? Well, the thing that's making the sound is the object that's being launched. So I'm going to call this our object is going to be the source of our sound. And our recording device, of course, is the thing that's recording the sound. So as our projectile moves up, it's getting farther and farther away from our recording device. And then as our object moves back down again, it's getting closer and closer to our recording device. So we've got relative motion here and things getting closer and farther apart. So what does that mean in terms of the Doppler effect? Well, remember the classic example with the Doppler effect is always that of an ambulance. If you're getting closer to an ambulance in traffic, that sound seems to get higher and higher pitched because you're perceiving the frequency as being higher than it actually is. Okay, so remember Doppler effect, two objects getting closer, you're going to perceive a higher frequency. So in other words, when is this object getting closer is when it's going down. So I'm going to write that this is going to be a higher perceived frequency, which we just say frequency prime, okay? And then if that ambulance is getting farther away from you, that sound seems to get lower and lower pitched. You perceive it as having a lower and lower frequency. So the ambulance getting farther apart from you would be like the object getting farther from the recording device or being launched upwards. This is going to be a lower frequency. So in other words, what's happening? Their object moves up, its perceived frequency decreases. But then when our object comes back down, its perceived frequency is increasing. The closer and closer it gets to that recording device, the higher that frequency is going to seem. So which of our answer choices seem to match that? Well, okay, first thing we're looking for is a decrease. So let's see. Answer choice D for me says it falls continuously. Well, we know that that's not the case because then the frequency after it decreases increases again. So we can cross off that answer that it falls continuously. And likewise, answer choice C for me says that it rises continuously. We know that that's not the case either. We have a decrease and then an increase. Okay, so two answer choices eliminated already. And then we also know it's not going to be constant throughout the flight. We said there's a decrease and increase, so we can rule that out. So then the only answer we're left with by elimination is that it falls to 0 and then increases, which is exactly what we said, right? It decreases, falls to 0, and then it increases. Understanding the concept of the Doppler effect, super important for the MCAT. Remember, you don't need to memorize that equation you'll see in all the Kaplan books for the Doppler effect. You just need to understand that if two objects have relative motion and they're getting closer together, you're going to perceive a higher frequency. And if those objects are getting farther apart, you're going to perceive a lower frequency than the actual frequency. So I hope this helps. If this helps, please give this video a like. Feel free to drop any comments and follow my channel for more content like this.